Okay, so classification of matter. How do we know what we've got and what can we do with it? So first let's talk about what is matter. Matter is anything that has mass and takes up space. So it has to have two things in order to be considered matter. Mass, which is the amount of matter, and volume, which is the amount of space that the matter takes up. Now take note that weight is a measure of gravitational pull on matter. So mass stays the same no matter where you are, but weight changes depending on the amount of gravity, such as you can weigh less on the moon than what you weigh on Earth. So matter is made up of particular things that you've heard of before: atoms, which are the smallest unit of an element, and an element is a substance that's made up of only one type of atom. Now molecules are the smallest unit of a compound, and compounds are a pure substance that is made up of more than one type of atom that's bonded together. So let's look at that as an analogy. Atoms are to elements as molecules are to compounds, as a brick is to a building. So atoms are the building blocks of an element, and molecules are the building blocks of a compound. So there are different ways we classify the properties of matter. The first way is extensive and intensive properties. Now, extensive properties depend on the amount of matter present, such as volume, mass, amount of energy, and size. Intensive properties do not change regardless of the amount of matter present. So these include density, melting point, boiling point, ability to conduct heat and electricity, the state of the matter, color, luster, texture, viscosity, which is the ability for something to flow, and malleability. The other way we classify the properties of matter are physical versus chemical properties. Physical properties are characteristics that you can observe without changing the substance, without having it react with something else. Examples of this include density, melting point, boiling point, color, size, mass, texture, volume, luster, viscosity, and so forth. Chemical properties, they tell us the substance's ability to be transformed into another substance via a chemical reaction. So these can only be observed if you change the identity of the substance. Examples include reactivity, whether something is combustible, oxidizes, stability, toxicity, and the pH. Now let's look at density a little bit closer. This is a physical property. You calculate this by dividing the mass by volume. And something to note about density is that no matter how much of the substance you have, the density will always be the same. So you can have 2 cups of water, and we know the density of that. And if you split that up into 2 separate cups of water, the density remains the same. And density is unique to the substance. No other substance will have the same densities. When a matter changes, we have 2 different types. We have physical changes and chemical changes. Physical changes do not change the identity of the matter, the substance. Examples of physical changes are tearing, cutting, grinding, ripping, melting, freezing, boiling, or breaking. Now, a few of those are an example of changes of state, and we'll talk about the states of matter in a little bit. But when you have a change of state, this is a physical change. It does not change the identity of the substance. It just changes the state, which we'll talk about here in a second. Now, chemical changes, these do change the identity of the substance. So examples of that include burning, rusting, cooking, when metals tarnish, and food spoiling. Now, how can you know if you have a chemical change? Signs would be color changes, an odor, light, heat, production of a gas or a solid, such as if you see any bubbles, or even a sound. Now, an important thing to note is that when matter changes, whether it's physical or chemical, they all involve energy in some way. And examples of the energy that it puts off or it takes is heat and light. Now, let's talk about the states of matter. If you'll notice, for solids and liquids and gases, you need to know a couple of things. You need to know that solids have a definite shape and a definite volume. So no matter where that solid is, it's going to maintain its shape. You cannot change its shape very easily, and its volume cannot change. And the reason this is if you look at the picture there, the particles of solids are very close together and they are arranged in a very organized fashion. Now, because these particles are so close together, they don't move very much, and energy that you get from particle movement is known as kinetic energy. So solids have the lowest amount of kinetic energy. Now let's look at liquids. Liquids do not have a definite shape. They take the shape of whatever container they are in, but they do have a definite volume. The particles in liquids, they do move past one another in a fluid-like motion. And let's look at gases. Gases do not have a definite shape, and they do not have a definite volume. And the reason for this is because the particles are moving so fast around one another, so the gas will take the shape of whatever container it's in, and it will also determine how much volume that gas has. Now, because the particles of gases move so quickly, gases have the highest amount of kinetic energy. Now, let's look at some different ways that you can change the state of matter. Condense, which is known as condensation, is when something goes from a gas to a liquid. You see this a lot whenever you have a very cold drink. You'll have water that'll form on the outside of that cold cup, and the reason is because the water vapor in the air condenses and becomes water droplets on the side of your cup. Crystallization is when a liquid goes to a solid. The particles slow down and they create a crystal-like structure, which is where it gets the name crystallization. Fusion is when a liquid goes to a solid, but instead of forming a crystal, it just forms a regular solid. Evaporation, this is also something you should be familiar with. When a liquid goes to a gas, the particles start moving quickly, and that causes the particles to bounce off one another and come out as vapor, which is a gas. Melting, you see this whenever we have a cube of ice that starts to melt into liquid water. The particles increase their energy, and thus they start moving a little bit faster, so it causes it to go from a solid to a liquid. When something sublimes, you go from a solid directly to a gas. The particles near the surface of that solid start bumping against one another, and they do that so hard that it sends them out into the air as a gas. Now, a different state of matter we haven't talked about is plasma. There is so much energy that it is electrically charged particles.